We have the equation y is x squared minus 3x, and we want to find the turning points and investigate their nature. The first thing we need to do is differentiate. dy dx is 2x minus 3. Turning points occur when dy dx is equal to 0. Therefore, we need to set 2x minus 3 equal to 0. Solving this gives us the x-coordinate of the turning point. Add 3 to both sides and divide both sides by 2. This is the x-coordinate of the turning point, and since there's only one solution, we only have one turning point for this curve. We want coordinates when x is 3 over 2. If we substitute into the original y equation, we'll find the y coordinates. So 3 over 2 squared, take away 3 times 3 over 2. This is 9 over 4. Take away 9 over 2, which is 9 over 4. Take away 18 over 4, which is minus 9 over 4. So the coordinates of the turning point are 3 over 2 and minus 9 over 4. To investigate the type of turning point, we can use the second derivative, d2y dx squared. To get d2y dx squared, we differentiate dy dx again. Differentiating this gives 2, and this is a positive number irrespective of the value of x, since x is not involved. If d2y dx squared is positive, we know that we have a minimum. So we have a minimum at the point 3 over 2 minus 9 over 4. The other way of investigating turning points is a sign table. We don't need to do both as I'm doing in this example. It's one or the other. Here's x values and dy dx. The turning point we know is at 3 over 2. A point to the left of this is 1 and to the right is 2. And in this case we don't need to worry about whether these points go past another turning point, since we've established that there is only one turning point for this curve. We know the turning point is at 3 over 2, so the gradient here is 0. When x is 1, we evaluate dy dx. We get 2 times 1 take away 3, which is 2 take away 3 minus 1, which is negative. When x is 2, we get 2 times 2, take away 3, which is 4 take away 3, which is positive. So we get negative, 0, positive, and we can see the minimum shape, which agrees perfectly with the analysis we did using d2y dx squared.